talk louder to talk over. Two different techniques. So we're moving to our second section to talk about plant parts. And plants have different parts. We usually don't really sit and separate them out and think about them, but it can be really helpful for understanding plants and especially diagnosing things that are going wrong, to understand the individual parts and what they do for the plant, how they're part of the whole. So if we're looking at this lovely Lagerstromia, crepe myrtle, how many parts jump out at you? What do you see there as parts of the plant? Flowers, yeah, flowers, leaves, yeah, you can see stems and the trunk. What was that one? Oh, racemes, yeah, that's part of the structure. So what is there? A really big, very important part of that plant, but you don't actually really see it. The roots, right? Huge, most important part, and people don't think about them because they don't see them. That tends to be where a lot of our problems in plants are. So yeah, so we know the roots are there. We don't see them. We see the stems and the trunk. We see the leaves. We see the flowers already open, but they were buds, and the leaves themselves were buds as well. The flowers, and after those flowers have done their thing, they will become seeds, which will be in little capsules. So these are the basic parts we're going to talk about. Starting off with roots as the most important. If you have to pick out one part, so they're all critical, but this is just the really important one that most people who aren't gardeners, who don't work with plants, they just don't think about the roots. And they do a lot of stuff that damages the roots. The damage shows up in the plant, and they think something's wrong with the plant, which it is, but they don't connect it with what happened to the roots underground, like digging and putting in a driveway right beside a tree and things like that. So roots have a super critical role. They are what absorb the water and minerals that goes up and keeps the plant alive. It keeps it growing. They keep it alive. They keep it from wilting. So when a plant is wilted, often it's a root issue. So usually when a plant's wilted, you think, what's wrong?
It's lack of water.
Yeah, lack of water. But it can be that the roots are not healthy. They can't take up the water. So you give plants wilting when the roots drown. So the plant might actually be too wet. The roots aren't functioning and the plant wilts because the roots aren't functioning to take the water up if you not give it more water. So that's, when you start talking about diagnosing plant problems and plant diseases, thinking back to the functions of these different plant parts becomes really helpful. Roots also store food, and these, like you see the roots on this tree, they're huge, large roots on woody plants particularly, so they can actually store starch, and they can store carbohydrates that are a food source for the plant in the future. And they support the stem. So, a big tree has to have a big root system to keep it anchored. And that's why you see where, I wish I had a picture of this, but I don't. When I was in New Hanover County, down in Wilmington, there's an arboretum that surrounds the office. And several years before I started there, an irrigation system had been put in an area where there were all these trees. So when you put in an irrigation system, you're digging all these trenches. So they was put in a grid, so they did these trenches and they put the pipes out. And a couple of years later, it was a hurricane. Every one of the trees grew over the same direction on the side where that trench had been cut to put the irrigation in. The roots got cut. The trees didn't have that support and they fell over. So we see that a lot, where sidewalks are put in, driveways are put in, anywhere where roots are damaged, you're cutting off that anchorage. And so a tree is much more likely to fail, to fall over when they don't have that support. Or just die, if you cut off enough roots, it just dies straight out. Although with trees particularly, it's not a super fast process because they have so much stored energy, they kind of can take several years. People don't always connect, the serious root damage that occurred with the tree dying 4 or 5 years later.
So above ground roots are not typically found, are they? That tree, you showed that, looked like there were roots, but
yeah, so that tends to happen. You can, not this dramatically, but sometimes with oak trees, you might get a lot of above ground roots. And that tends to be more related to the conditions of the soil. roots are gonna grow where there's air and moisture. So you need air in the soil, it needs to be fluffy. If your soil is really, really compacted, then you'll get more surface rooting because the roots have a hard time growing into the soil, the air isn't there. And also if you have in some situations like a high water table, like the water, especially if you go to the eastern part of the state, you have the water table coming up within a few inches or up to ground level certain times of the year, so you get more surface rooting.
Well, that reminds me, if you've ever looked at the Dredge Kelmer forest out in the western part of the state, which is a virgin hardwood forest, it's the only one on the East Coast. These ancient poplar trees have roots like that.
Roots like that, yeah. So you wouldn't expect the soil to be compacted in the national forest. So maybe it's a situation of age or,
I think age.
yeah, age. You know, some oaks tend to be a little more surface, you know, have these larger support roots up at the top, but a lot of times rooting at the surface is a reflection of soil conditions.
So how do you prevent that from happening?
Well, you do a really good job of preparing the soil before you plant, but once this has happened, you can't really prevent it. Don't try to grow grass there, it's not going to work. Just kind of let it be. So when we talk about root systems, there's two main types of root systems with plants. Fibrous, which branch a lot and have a lot of fibers. So you can see the picture here, this is a really fibrous root system. There's lots of small roots spreading out. And as you can imagine, that does a great job of holding the soil together. So plants, really, one of their huge functions is just to hold the earth, the soil in place, to keep everything from washing away. And plants with these type of fibrous roots are particularly good at it because they have lots of these tiny roots that then just infiltrate and all around the soil particles and hold them in place. Whereas other types of plants have a taproot. So instead of making lots of these fibrous branching roots, they make one big, thicker root, which stores a lot of energy for the plant. That's typically why they have the taproot. You often see plants with taproots evolve to grow in areas where part of the growing season is really harsh. So they have to store energy to survive that time, or like to go dormant during that time, and then have that energy reserve to get started growing again when the conditions get better. So carrots, quite a few of these plants with taproots, carrots, parsnips, horseradish, horseradish. We eat them, because there is all that stored energy in there. Carbohydrates, sugars, they taste good to us, and they're nutritious. So taproots, another thing, some plants that have taproots can be difficult to transplant if you cut really close to the top. So with a fibrous plant, if you were to dig around, even if you were to cut here, you would still get quite a lot of those fibrous roots. And if you were to be really careful about transplanting it and keeping it watered, it would probably survive. But this taproot plant, if you were to cut it off up there, I mean, it's lost tremendous amounts of roots, so it's probably not going to survive. You have to dig much deeper to get enough of the taproot for that plant to live.
Okay. Well, that picture's up. The book talked about this thing called the meristem.
Mm-hmm.
Is that the top part of the root before the fiber stuff comes out, or?
Well, the apical meristem is usually the tip of the root, where the new growth is.
Where all the new growth
Where the new growth comes from. Yeah.
Thank you. I was having a little hard time.
Yeah. So this next picture we have, a root, and so roots do grow from the tip.
Okay.
So that's the meristem,
That's the meristem.
where the new cells are being added to the very tip. So the growth is not being pushed down from up here; it's elongating from the bottom. So you can imagine if your soil is really compacted, and that root's trying to put on more layers of cells, and it's pushing against really, really compacted soil, those cell layers are going to be really thin, and it's going to be much slower, the whole process. So in compacted soils, you get much slower and kind of stunted root growth, just because the plant cannot force those cells into their soil, which is so hard. So you want your soil to be fluffy, you want to have a lot of air in it, actually air space, so that those cells can elongate and grow and infiltrate through the soil.
Would clay soil be considered compacted just by its nature?
Definitely. Clay soils, because the particles are so tiny and they just Yeah, stick right on each other. They, even in a natural state, can tend to be more compacted than, say, a sandier soil. But that helps them hold moisture, but then, so there's pros and cons to each soil type. If you get too much of any specific, sand, clay, silt into it, there's pros and cons. But if we as gardeners want to amend our soils and add compost, so bring organic matter back into the soils, which tends to be there in nature, but when we come in and start taking things over and moving the topsoil away, we take a lot of organic matter away. We have to do a lot of work to bring that organic matter back into the soil to make it a state that plants and their roots specifically grow happily and easily into the soil.
So for the fibrous roots, would you call the tip of all those meristems, or is it just?
Yeah, the tip of every root is a meristem. Yep. And the other thing you'll see on roots, especially on young seedlings, are these very fine hair-like roots, and so they're called root hairs. And like I said, if you've never sprouted seedlings and you're transplanting them, you may see that. And they're just a way when the plant, especially if it's just getting going and it has a very limited root system, it gives it a way to absorb more water because it greatly increases the surface area of the root system. If you were just talking about the surface area of this main root, it's going to be much, much smaller than if you talk about add to it the surface area of every single one of these little hair-like roots. So they help the plant absorb water. And they're short-lived, the root hairs. So when you're transplanting seedlings, if you break some of them, or if they just don't, make it, that doesn't mean your seedlings do. They can regenerate those pretty quickly. With woody plants, you have a permanent root structure. So with herbaceous plants, usually they tend to grow new roots every year. They have some kind of either storage root or a bulb or a crown. So they have some part of their root system that does stay alive even through, say, the winter, for things that go dormant in the winter. But they push out new, kind of the equivalent of feeder roots in the spring. They grow those new roots out. But with woody plants, you have a much more permanent root structure all throughout the soil with these structural roots, and the larger roots on trees are there to anchor it and to provide the structure to get the finer feeder roots further out and out into a greater area of soil so that it can scavenge for as much water and nutrients as possible. So the permanent roots, if you cut a lot of those, you're really harming your tree's stability. It's much more likely to fall over. And also you're cutting off, or you're disconnecting it from all the finer feeder roots that were connected to that part of the structural root system, say if you were to cut over here. So you're removing a lot of the tree's ability to take up water and take up minerals. So whenever possible, damage, you don't want to damage the root systems of plants, particularly of large trees. But they extend, much, much further than the canopy of the tree itself. So people don't always realize, even though they're not right underneath the tree, they can still be causing a lot of damage.
So if you take a tree out by its root system because of whatever reason, sometimes, it's obviously very difficult to get the entire root system out. So it ends up being sort of right around the base of where the trunk is, and then later new plants come up off of the roots that are still under the soil.
Some trees can do that.
There's some trees.
Yeah, some trees, crepeworm, yeah. So some perennials as well, so some perennials and some trees have the ability, like exactly, if you were to dig it up and remove all of this main part of the root system, this stuff left out here could produce new buds and grow. Yucca, if you've ever had a yucca plant, the spiky yuccas, you dig one of those up, you never get rid of yucca. You just create a whole bunch of them every time you damage the roots. So so there are some plants that can rejuvenate from the roots. Most trees don't, but there are definitely some that do. So the feeder roots are the really critical part of the root system. They're what's taking up the water and nutrients, and they're what tends to be found in that top foot or even 6 inches of the soil, because that's where there's more moisture, there's more nutrients, and there's more air in the soil. So the structural roots can grow deeper and grow into less hospitable soils, but the feeder roots are gonna stay where what they're looking for is, is there. And they're looking for water and minerals, and they need air, a certain amount of air in the soil. Feeder roots can grow up as well as down. We think of roots just growing down. So if you've ever had a compost pile in a shady area or close to some trees, and you go to try to collect the compost, and you stick your shovel in, and it kind of bounces back, and it's hitting a lot of roots, that's where the tree's feeder roots have grown up into your compost pile, and they love to do that. And they're most concentrated at an area called the drip line. So the drip line is here at the edge of the canopy. So the drip line, if you were to think about this as being a raincoat, so all the water that falls all kind of rolls off to the sides. The drip line is there at the edge of the canopy where everything is dripping after it rains. So if at all possible, if you are doing something around the tree, you want to avoid doing anything. Definitely never work from the trunk out to the drip line, and then, from the drip line at least, 4, 5, 6 feet, or much more is much better. But at least, avoid that drip line area for disturbing it. The further you get away from the tree, the better it's going to be for the tree as far as you're going to be impacting less of the root system. So roots are critical. Next we have stems. So we don't think about stems as playing a critical role of something like roots, but stems are really important in making plants what they are, because that's the difference between vascular plants and non-vascular is stems. Stems' ability to move those water and minerals up into the plant. If we didn't have stems, our plants would just be a pile of leaves and flowers on the ground. The stems would hold things up and space them out. They space the leaves out so they can intercept the sunlight. Just have a stack of leaves on top of each other, only one on top is going to get sunlight. That's what leaves are all about. So the stems help spread them out so they can all intercept sunlight. They hold the flowers out, they hold the buds. They really provide the structural support. And they're also transporting food, minerals, and water. And they're doing it in this vascular tissue. There's two particular types, xylem and phloem. And xylem only goes up from the roots, and I can never remember this. That's why I put the arrows on the slide, so I can look at it quickly and say, yeah, xylem only goes up. I have not come up with an easy way to remember that, if anybody could ever think of it. So xylem is what's taking the water and minerals that are absorbed through the root system and taking it up to the leaves and the rest of the plant. And phloem goes both up and down. So it's helping take food produced in the leaves through photosynthesis down to other, or all throughout the plant, not just down, but throughout up to other parts of the plant, as well as hormones that are produced within the plant. It's transporting all that stuff around inside the plant. So we have some insects that feed on vascular tissue, and do you think they choose the xylem or the phloem? Phloem, yeah, they choose the phloem because that's where the food, that's where the sugars are. So you have things like aphids, little aphids that get on plants, and they're plugged right into the phloem, and they are just feeding. They're just constantly feeding on this sweet sap moving through the plant, and it's coming in their front end and going out their back end. So they produce a lot of honeydew, which is just a nice word for bug pea. And when you get aphids, when you get these phloem feeding insects, you tend to get a lot of this sticky honeydew. Then you get waxy mold, which is this dark, sooty looking mold that grows on it. And, you'll learn lots more about that when you talk about insects.
Can I suggest phloem falls?
Phloem falls.
Phloem falls. Phloem, P-H, and fall. It's the only one that goes down, it falls. Phloem falls. I know it also goes up, but it's the only one that goes down.
Yeah, the one that goes down.
I'm just making sense.
Yeah.
Xylem to the inside, phloem to the outside, because the xylem is the heartwood of the tree or making the tree.
Yeah, perhaps, that's the next picture I have. Yeah, we'll keep working on these ideas. We'll have a way to remember it. So in woody plants, we have the xylem and phloem arranged just underneath the bark. So if all of your vascular tissue that's conducting, so that xylem particularly, if that's conducting water up from the roots to the top of the plant is just under the bark. Say you're out weed trimming one day and you have, grass growing around the base of the tree, so you come and you just trim that grass and don't realize you've also cut the bark right around the right around the base. 3 or 4 days later, what might you find happens to that tree? Yeah, it's all wilted all of a sudden, and then pretty soon it's probably dead because you've cut off all that vascular tissue that the plant relies on. Most of what's inside the trunk is just kind of inert. It's not doing anything necessarily for the tree. The actual living part that's moving those minerals and water and transporting that food around is just beneath the bark. And some people have used this for botanical terrorism. When my husband's from New Zealand, he lived there for a while, and there's this famous park in Auckland called One Tree Hill, and there's a big old pine tree that grows on it, and some people are happy with it because it's not a native tree, and so they ring mark it. That's the term for it, is ring marking it. And sometimes people will do it on purpose to kill a tree, is ring mark it. So you just go and cut right around the outside. Cut through the bark, and you just cut in. It doesn't take much, and especially for really thin bark trees like maple and dogwood, doesn't take much at all. And you will kill the tree, and you can't really help it recover. In this one situation, they went through all kinds of efforts to bring grafting in little pieces to try to reconnect it, and they kept it alive for a little while. But anyway, so ring barking can be an easy way to accidentally or intentionally kill a tree. And one thing you find with woody plants, which we've got some twigs on your table, is that layer, where'd I go? Yeah, that layer where the vascular tissue is green. So the bark on the outside, typical bark. When you get to the twigs, like you have here, the bark tends to be really thin, and a lot of times in the winter or in the spring, especially when we have a cold winter, people are wondering, well, is this even alive? Is this part of the plant still alive? Particularly things like gardenias, figs. Figs can often get some winter damage. So an easy way to check is just to lightly scrape that bark. So if you pick up one of the twigs on your table, just with your fingernail, just lightly scrape it. It should be green underneath. And it's alive. So if it's recently died, sometimes you can tell it's kind of yellow or it's already brown. If it's been dead a long time, it's just dry and brittle, so you can't just snap. You don't have a great scrape.
So what you have labeled as wood is
just the interior, yeah.
So is the interior what used to be xylem?
Yeah, because that's
So
absolutely
does that
right.
mean that the tree every year generates a new
Layer.
xylem flow? So that means xylem flow only is only active a year?
Yeah, so that's why you get the rings in a tree. You're seeing that new layer being added every year.
So only the outer layer is active. The rest of all that stuff in the center is no longer active.
Right. It's no longer active. It might be doing a little bit in there, but it's not moving around nutrients and water. That's only happening on the very outer layer.
And what is the cambium? In the book, it sounds like cambium is this vascular structure.
It's part of that vascular tissue. So if you see on the picture, you have the xylem is the closest to the bark, the most outer layer. The phloem. The phloem is the most outer layer.
Right.
Then you have the cambium, which is kind of that dark little zone, and then you have the xylem on the other side. So you would never see that, like just cut it. You would see the ring system. So you're basically seeing the dark and light pattern. But that cambium is where the growth occurs. So we talked about, like at the root, the growth is occurring at the tip. In the trunk, the growth is occurring in the cambium layer. That's where cell division is happening. So the tree is growing outward through that cambium layer, it's putting on those new layers. And so you can think about every year that tree's putting on another layer. I saw a great lecture one time by an arborist who started standing up. It's like, I'm a tree growing. And he just started off with a t-shirt on, and he put on a jacket, and he put on another coat, and he put on another, then eventually, he had all these dirty coats put on, So that's how a tree grows. It puts on a new layer every year. That's how it grows and grows.
So is the cambium the region of cell differentiation as well? So does the cambium then
Differentiate into xylem and phloem.
xylem?
I believe so. It's been a long time since I took botany, but yes, I'm almost certain.
So if a sycamore loses its form, it's not.
Right, so some trees, like sycamore, they'll all take some taking botany to adapt up. Yeah. But yeah, some plants shed their bark, like sycamore, eucalyptus, crepe myrtle, and that's good. That's natural. They just do that. They produce the outer layers of bark they produce are kind of like we shed skin. So trees that are, that's part of their genetics to shed bark, that's fine. Particularly with some of them like eucalyptus, it's help them adapt to fire. So the shredded bark that hangs on eucalyptus burns off really quickly, and the fire moves on without really damaging the tree. That's not why sycamore shed bark, but I don't know why they do. But anyway, but usually though, shedding bark's a really bad sign. Usually bark is kind of stuck to that living layer and is holding on to it. And if you get a tree like an oak tree, which normally doesn't shed bark, and get large chunks of bark falling off, that's a really serious sign something's wrong.
In the book, it says a vascular cambium is responsible for the stem's increase in diameter as it produces both secondary and phloem design tissues. So,
Yeah, that's where the difference. It's growing, either side of it. So a couple of things that you see on stems that we do talk about some, especially when you're talking about propagation and pruning, you'll want to know where on the stem to cut. That's always the question, all right? So we talk about the nodes and the internodes. So the node on the stem is where there's a bud. And so you can see on the stems on your table, particularly the long skinny stems, you see the little bumps. Those are the buds. Those are going to be where the new growth occurs. And where that bud is, that's the node. So when you're going to, and a node is a really active area for growth, for root initiation, for cutting, for new growth to come out if you prune. So if you were going to prune the stem and you cut here, so you cut that bud off, you cut below the node, do you think anything's going to happen in this piece of stem? No. Yeah, for most plants, nothing's. Some plants will go crazy and produce all kinds of adventitious buds, but for most plants, that piece of stem is just going to kind of die back, and the new growth will come from this node. A lot of times it's just a cosmetic thing, but sometimes that dying piece of stem can be a way for insects or diseases to enter the plant. So, if you're doing very precise pruning, where you're individually making cuts with pruners, you would always want to cut just above the node, so you didn't have these little dead stem pieces left all over the place. And the absolute opposite when you're taking cuttings to propagate a plant, because the node is the area where you typically get root initiation. So if you cut just below the node, you have an area where you're most likely to get the plant to produce roots. Whereas if you cut just above the node, that piece of stem is probably just going to rot stuck in the soil, especially for woody plants. Of course, with some things like coleus and sweet potato, they'll root anywhere. You throw it on the ground and it rains for 3 or 4 days. So take note of the nodes when you're pruning and when you're taking cuttings. Cut just above to prune and just below to propagate. And then the internode is just that space in between. And so one thing you'll notice when plants are leaning towards the light, the internodes get really long, so the leaves get much more spaced out because it's growing towards the light. Whereas plants that are naturally compact, the internodes are just much shorter, and the leaves are much closer together because they don't have as much space because they stay smaller. There's a couple of different types of stems, of course. The woody, typically we think about woody plants, but of course herbaceous plants, all vegetables, perennials, annuals, they have stems. So herbaceous, doesn't have the lignin, it doesn't have the woody, it doesn't have the bark and the woody structure that keeps it above ground year round, so it dies away and it breaks down really quickly. So that's why when you clean out your vegetable garden, you throw everything in the compost and it breaks down really quickly, there's not woody tissue there or lignin there, break down. Then we have what are called canes, which are kind of halfway between being the herbaceous and woody, and this would be things like roses and blackberries. So those stems on those kind of plants tend to stay relatively green. And if you cut into them, it's harder to cut into them than say like a herbaceous plant, perennial, because they're a little bit more thickened and reinforced. But it's not like cutting into a tree branch. If you cut them open, it's usually kind of white inside, and that's called the pith that's inside. And these canes typically live individually for 1 to 2 to 3 years. So they're kind of halfway between. They don't die down every year, but they only live maybe up to 3 years. And then the other woody stems would live for many years.
Yeah, you can. We also just.
So, sometimes when you hear somebody talk about canes, they're usually talking about something that rose down. In fact, that whole group of blackberries, raspberries, boysenberries, there's a whole bunch of them are sometimes called caneberries. You might see that term because they all grow from those canes. There are some modified stems that plants have that we typically think of as roots, but from a botanical standpoint, they are modified stems, and that's helpful from a propagation standpoint because stems have nodes, stems are able to produce these adventitious buds, so you can propagate from them, although some roots can do it too, but not all. So some modified stems that have become root-like structures include stolons. This is the strawberry plant, so stolons are those, or like a spider plant, they're those long, they do look a little like a stem. They kind of shoot out from the plant and have little baby plants on the ends, so they help the plant spread out. And then rhizomes. Rhizomes are these very thickened, storing a lot of energy, storing a lot of food for the plant. This would be an iris rhizome. And so some plants that have rhizomes, like iris, have these short, thick rhizomes that, just reproduce at a nice rate. They multiply and make a nice clump of iris. Other plants that have rhizomatous roots, from 1 year to the next, may go from me to the middle of that table, so they can really spread very quickly. Things like bee balm, mint, you ever plant spearmint? Yes, and some plants have both. You're right, mint has both rhizomes and stolons. Bermuda grass has both rhizomes and stolons. Creeping Jenny, I think, is more just stolons. Yeah, the stolons. Yeah, it's up on the top of the ground. So the plants with the rhizomes and stolons tend to be even, more vigorous than just stolons alone. Plants that just have stolons are a little more sensitive to cold because the stolon stays on top of the ground, whereas the rhizomes are actually in the soil. You see that sometimes in this area, if anybody tries to grow centipede grass, we're just our fluctuating spring temperatures often damage it, but centipede grass just has stolons. They're just on the surface, and they're much more sensitive to cold, whereas Bermuda grass has stolons and rhizomes, so all those rhizomes in the soil are much more insulated than just stolons on top. So in general, though, when you hear about a plant that has stolons and or rhizomes, you want to read a little more about it before you put it in the ground, because it might be something that you can never get rid of. It's going to spread very quickly.
Is there any connection, familiarity between rhizomes and tubers, or do they just happen to look alike?
Tubers are another type of modified stem. So again, it's kind of the tubers and forms and bulbs aren't as much about spreading as they are about storing energy. So kind of like those plants with taproots, tubers and corms and bulbs tend to have evolved on plants that grow in regions that have a really harsh part of the year. So they need to be able to grow when the conditions are good, and then when it gets too cold or it gets too dry or it gets too hot or for whatever reason that plant needs to shut down, it needs a way to have stored up all this energy it produced while it was growing, while conditions were good. And then that storage organ just sits there in the ground until conditions become right again. And it gives that plant the energy to get back up and going.
What about nodes that are not like a disease, like root nodes? Aren't there some plants that have nodes on them that are more thicker?
These modified root systems will have nodes.
Okay.
sometimes.
Is that the same thing for storing energy?
Oh, nodules, I'm sorry, I'm thinking, yeah, so nodules, yes, so there are nodules on root systems are a relationship with bacteria that help those plants take up nitrogen. So y'all, you haven't had soil science yet, right? No. So you'll talk about nodules on roots, which look like little bumps. Oh, well, actually, they're more like they're kind of attached to the root, a little
So it's
barb.
related more to disease than to energy consumption.
Right, the nodule is something that forms from the beneficial relationship with the bacteria in the soil. You see most of the legumes, peas and beans.
What's the difference between corn and a bulb?
There are, so if you slice into them, you can tell the difference. Like bulbs are more like onions where you have layers.
Yeah.
Corms are more pressed.
But they do both have the same kind of stuff in them, just shaped.
They're they just form and are shaped a little differently, but they're both to store energy.
Yeah.
And it really, if you really were to get into real detailed propagation of a bulb versus a corn, there would be some minor differences in how you do it.
Okay. But in general,
It's the same purpose, storing energy. And to really get around those harsh conditions. The corn is more like this one, like crocus, gladiola are corms, daffodils are bulbs, dahlias and potatoes are tubers. Yeah, it's just to make it confusing, that's right. That's right. Absolutely. Of course, and bulbs and corms do have an upside. There's usually you see a little bud, especially on corn, you see bud. But sometimes it can be difficult, so if you're ever confused, just put them sideways, they'll figure it out. You plant it upside down, but they'll still figure it out. Because plants do have geotropism, they can detect gravity, yes, that's the word. So the roots know to grow down and the shoots know to grow up, so they'll figure it out. All right, yeah. So that was stems. So attached to the stems are buds, and this is a great time of year to look at buds because buds are starting to swell on plant stems. And the leaves aren't there yet for all of these deciduous plants. So you can see them really clearly. And if you really get into winter plant ID, which is its own field, because a lot of it relies on minute details you don't pay attention to in the growing season when you can see leaves and flowers. You'll get into really learning about the many different shapes of buds, the scales that cover them. I think that's the chapter gives illustrations and things that all of those kind of details. But the thing I think is really important to think about for buds is they are a resting state for growth. So that is the flower or the leaf or the shoot that's going to grow out next year is in that bud. So right now, I think almost all the stems I have on the tables, the buds are very alive. You can see they're plump. If you were to scrape one off, you can see it's fleshy. So you feel free to scrape one off, they're kind of fleshy.
Can you tell us where the summer?
Yes. The one, we haven't talked about this yet, but the one that's kind of reddish colored, it has the buds that are arranged opposite of each other is maple, red maple. The one that has the buds that are alternate going up the stem is corylus. I'm trying to think of a common name, American hazel. Yeah, American hazel. And the other one, several of you noticed when I was doing dogwood, you see the flower. So you can see the buds look different on those plants. You can, in the winter, you can see the bud arrangement, which is equal to the leaf arrangement on the plant, which is a real big thing about identifying plants. You can also see the difference between flower buds and leaf or shoot buds. So flower buds, in general, are always going to be plumper and rounder on the plant than the leaf bud. So if you look at the dogwood, more branched one, you'll see those big flower buds. And I always remember when I was little, my grandmother, she would go out and she would look at the dogwood tree and she'd say, in the winters. We're gonna have a lot of flowers on that dogwood in the spring, you know, versus another one. So that one's not gonna bloom very much. Like, what kind of magic is this? She was looking at the buds in the dogwood. It's really, really dramatic. You can see right now. And so once you see those dogwoods that on the sunnier side, you say especially with dogwood at the side of the woods, the sunnier facing sides will have a lot more flower buds than the shady side. I want to let you know I did not sacrifice a dogwood. DOT went through and chopped back the trees on the roadside, and they happened to hit a dogwood. And I was walking, I'm like, wow, nice dogwoods, Tim. That's where it's coming from. So the flower buds, you know, even on, like right now, if you went out and looked at peach trees or blueberry bushes, you'd be able to see the flower buds were much, much rounder and plumper than the leaf buds, which are going to be very narrow. So on the other trees, those are leaf buds, most likely, because these fieldworks were pushing out some flowers lower down the stem.
So the plants bud out way earlier than, I mean, you said it was a resting state.
We'll talk about that in just a minute. Yeah, we're going to get to it. So you can tell flower buds from leaf buds typically, especially this time of the year. The bud is the resting stage. So the bud is also the hard, it's very hardy. So once the bud starts to grow and open up, it becomes much more sensitive to cold weather. So if it starts to grow too early, then we get more cold weather, it's going to be damaged. And how does the plant know? Well, actually, I had this slide first. We'll get to the next slide. How does the plant know when dormancy is finished? So that resting stage is called dormancy, when the plant's just waiting for growth to begin again. And plants can measure day length, they can measure temperature, they can sense moisture levels, and all that stuff triggers plants to go into dormancy. So in the fall, as the days are getting shorter and it's getting cooler, and usually fall tends to be a little drier, not this past fall, and the plants kind of shut down and go into that dormant state. Then after it's been cold for a certain amount of time, they know, okay, it's safe to start growing again. And the days are getting longer, it's time for me to start growing again. And the way they keep track of that, we call it chilling hours. Is that the question?
Yeah, I wanted to ask, does the chilling time need to be uninterrupted in the same way that dark needs to be uninterrupted in the photosynthesis cycle?
It's better, but it doesn't have to be, because it's never going to happen in this climate, right? So chilling time is what that plant keeps track of, these chilling hours, how long it stays cold. And ideal chilling time is actually not below freezing. It's between 32 and 45 degrees. That for the plant, that's a whole half. An hour at 35 degrees is an hour of chilling. And we know for specific plants how many hours at those temperatures they need before they're ready to grow again. And those are the chilling hours. We particularly talk about with fruit trees. And if it gets a lot colder, it actually can have a negative effect, kind of like subtracts some time off. And if it gets much warmer, it kind of disrupts, the timing. But ideally, the optimum chilling is 32 to 45. And once a plant has accumulated enough chilling hours, say a peach tree has accumulated enough chilling hours to meet its dormancy requirement, as soon as it gets warm enough, it will start growing. And peach trees and plum trees are some of the worst for wanting to bloom early. Peach trees are from China. And in China, the climate where they're from tends to be much more gradual. It goes from being cold to being warm, and it's just a gradual change. It's not like here. Our springs are very erratic. It can be 70 degrees for 3 or 4 days, and then, like next Monday's going to be 32 degrees or something crazy. So we get a lot of this up and down weather. So our native plants that are adapted to our climate tend to have much longer chilling hour requirements than trees and plants from other climates, because they know, don't let that early warm spell fool you. Just sit here and wait for several, 100 more hours. So with fruit trees, it gets really important to choose cultivars that have chilling hours matched to what we typically get for our area. And we're in this kind of 800 to 1,000 chilling hour region. So if you buy a peach tree that's rated for 200 chilling hours, which some of the ones they grow down in southern Florida are 400. You know, on the Gulf Coast, if you plant that 400 chilling hour variety here, what do you think's going to happen? It's going to come out and bloom way too early, and all the blooms are going to get frosted, and you're not going to get any peaches. The tree's going to be okay. In fact, the tree's going to grow like crazy because it doesn't have to form any fruit. All the energy can go into growth, but you're rarely going to get any peaches. Same for apple trees. Apple trees, you tend to see the opposite. A lot of apple trees have really, really high chilling hours for colder areas. So if you get one with really, really high chilling hours, what tends to happen if the plant never gets its chilling requirement satisfied, the flower buds don't mature. They don't form into flowers. So the tree will still grow, but it just won't bloom and produce a lot of fruit. There's been experiments or attempts to grow apple trees in the tropics, and after a few years they just die because plants that are evolved to have a dormancy need that dormancy. You can't just make them keep growing. I feel like if you just try to stay awake for the rest of your you would die. So it just can't be done. So plants need to go dormant. Plants that evolved in temperate climates need to go dormant. And they need to stay cold for a certain amount of time so they know when to start growing.
That's right. How would you know this? Like, you're choosing varieties. Like, how would you know that this one is like a better choice versus this one? Like, how would you find that information?
You would look in the fruit tap or the Extension Gardener handbook. That's one. So there's a lot of extension publications. Yeah, that list the cultivars and their chilling hours. Some companies do a really good job on the tags, and they might put some of that information, but it's uncommon. So I would go to an extension or university publication, a book on growing fruits. That information tends to be published, somewhere in some of these resources. So do your research before you go buy the plants. Know which ones you're looking for. A lot of the blueberries now that I see, especially in places like Lowe's or Home Depot, there was this huge push to grow blueberries on the Gulf Coast and in Florida. They were doing it for several years. I think they kind of pulled back on it. And so now all these blueberry cultivars that were bred for the Gulf Coast are being sold in garden centers. And they only require 400 chilling hours, and I just think I want to stand out here and tell everybody, don't buy these blueberries, don't buy these blueberries. These varieties are going to bloom too early because we have wonderful blueberries. We have a very productive blueberry breeding program, of course, based out of NC State, that's come up with all of these great varieties of blueberry for North Carolina, as you can see in the book, that aren't going to bloom too early, whereas a lot of those newer ones now. Trying to think of some specific names. One of them has sunshine in the name. They're just going to bloom too early. So definitely research your cultivars for fruits. This is where it's so important for fruits before you plant. Because this is what happens. They just bloom too early, and then it gets cold, and the blossoms are killed, and the young fruits are killed. So we tend to see a lot of that fluctuating in February and March as we're getting towards the end of the dormancy period. Things are just ready to pop and go. And so you get those couple of days in the 60s and 70s, the blooms start to open. Like I said, as soon as that bud starts to open out, it becomes much, much more sensitive to cold. And you get that type of damage.
It was bad last March.
Yes, yeah. Yeah, a lot of damage. The other thing about buds is a lot of plants have the ability to produce buds that aren't obvious there right now. There's pre-buds waiting there underneath the bark, underneath the tissue. If the buds get killed or the buds get cut off, then the plant can make new buds and push them out. And those are called adventitious buds. So it takes some kind of dramatic event, like DOT going down the side of the road with a whacker and cutting everything off, or somebody deciding that holly tree was way too big. We're going to take it back to just a very basic framework. That type of pruning actually has a name. It's called hat racking. You can do it to some plants like hollies, especially some of these broadleaf evergreens. You just take it back so it literally looks like a hat rack, and it will survive.
The plants. So this goes back to trying to understand. Do they form their buds that are dormant before winter, and then they hang out, and then when they're ready to open, that's the...
Yeah, so the the buds are forming in the fall,
Which is like this.
and those are the buds that
Yeah.
formed in the fall, yep, and then they open up in the spring,
Okay.
yep. Yep, so plants, especially plants that bloom in the spring, they have to form their flower buds in the late summer and fall.
Because they can't do it, there's,
Right, because the
they
bud.
gotta be ready.
That's right, they gotta be ready, so that's why with things like azaleas and camellias, the spring blooming plants, we always say prune after they bloom, unless you're willing to sacrifice the blooms, because if you were to go prune them right now, you cut off all the flower buds. Whereas something like the crepe myrtle that blooms in the summer makes its flower buds on new growth, so you can prune it now and it'll still bloom. So summer blooming plants bloom on new growth, and spring blooming plants form those buds in the late summer and fall. And say if we have like a severe drought in summer and fall, that really affects flower bud production for the next year on things, on fruit trees, on, spring flowering plants. So if a plant gets really severely cut back and all of the formed buds are cut off, many plants do have the ability to make new buds, like they call adventitious buds. It takes time. So when you do this to a plant, it might be a month before new growth pushes out. Where we see this a lot on figs. Figs, their roots are hardier for us, but a lot of times the above ground part gets frozen or part of it gets frozen, especially if we get the mild weather, February or March, and it wants to start growing, then that gets frozen. The fig probably isn't dead. It'll probably send out shoots from the base or from the stem lower down, but it has to take some time to form those buds and push out that new growth. And so what would happen in this situation, it might take, with this type of severe pruning, it might take they would start to put out new growth within a couple of weeks to a couple of months. And then it might take a couple of years, but it would eventually get back to this fullness.
What is the word adventitious? We have seen it in several different contexts.
To arise from
Unusual places.
unusual places,
Not
yeah.
expecting it, odd.
Yeah, to arise from unusual places, yep, to come out where you didn't expect it. Or advent, meaning the birth, adventitious. Not, so it wasn't obvious. So there are some things though you cannot do this to, and conifers are one of the big groups. So in general, conifers will not produce adventitious buds. So if you, so this picture, I know you can't make it out clearly, but say you had something growing in front of here that caused all this part to die off, or you cut off all the stems right there, they're not going to grow back. You're always going to have an empty spot right there on that plant. Some growth might come in and like just kind of grow into that open area from the sides, but new buds aren't going to form on this bare wood to come back out. So
Could you notch it?
Could you not?
Could you notch it?
To make it, no, they still wouldn't form new growth.
Rats.
Yeah, so that's how, if you've ever seen these, I used to have a picture of this in here, and I think I took it out, but these topiaries, like junipers and things grown as topiaries, so you might have a stem, you have like the trunk, and then you have a little, and then you have the stem. And so nothing ever sprouts on those stems, because these conifers can't make those new buds on those stems. You try to do that with a crepe myrtle, for example, it just sprouts all over the place. You could rip the sprouts away. And crepe myrtles produce adventitious buds like crazy. So be careful with pruning conifers. And lavender and rosemary are very similar, they're not conifers. If you cut back to what's just, the twigs, the stems, where there's no green tissue, you've probably killed the plant. There's a fine line between cutting it off and too much. So typically, if you're going to do any pruning, stay within the place where leaves are still attached. And they can produce new buds where there's still living leaves, but you get back to the bare stems that have no leaves, you probably aren't going to get some buds forming. And then that brings us up to flowers. So some buds become flowers, some buds become leaves. Flowers are what, gardeners and people in general get really excited about for plants. That's what, they see. It's like, wow, flowers. They're colorful, they're cheerful, but really they're all about reproduction, for the plant. That's their purpose, and that's why they are colorful. That's why they do smell good. They're trying to help facilitate reproduction. Only mature plants produce flowers, so you do have plants do go through a juvenile stage, and at that point they can't bloom. And for most vegetables or annuals, you don't even think about it because it's so short. But for woody plants, that's where it becomes more important, our minor crop, because trees, you grow a tree or a shrub, say a camellia, that's one we often get a question about. People grow camellias from seed, like that camellia is 6 years old, it's never had a bloom, will it ever bloom? It will eventually, it has to get old enough. And it's not like a magic change or something that you really see visually, it's just it gets old enough to perform blooms. Got all kinds of reminders telling me, don't I? I have a meeting this afternoon, so now we all know. Some plants, like orange trees, if you were to ever grow an orange or a lemon tree from a seed, there is a really huge change from the juvenile stage to the adult stage. Has anybody ever accidentally or intentionally grown an orange or lemon from seed? What are those seedlings? What's different about a seedling when it comes up? Have you ever? Was it thorny?
No.
Really? Most citrus trees, when they sprout, will be thorny. Which one?
I have a big, I guess, big grapefruit, little sapling that's pretty thorny.
Did you grow it from the actual seed?
Yeah.
You started the seed, but it wasn't thorny when it sprouted?
It was thorny probably like second year.
Okay, yeah. So in the juvenile stage, they'll be thorny. Most of your citrus fruit will be thorny. Maybe not the first shoot that comes up out of the ground, they'll develop thorns. And then as they mature, when they get mature, they lose that thorniness. So there's some plants that there is a real obvious thing, but most plants do not. The other one we get a lot of questions about are pecan trees. The pecan tree just comes up from a pecan, it's probably going to take it 10 years before it ever gets mature enough to bear. And then it will only ever bear if you have a different variety to pollinate it. They have to be cross-pollinated. So some of these woody plants do take quite some time before they become mature enough to produce flower buds. You can't really speed it up. I don't know. My whole computer didn't like me telling it to. It looks like the whole thing might be frozen. I know, this happened I've never had this happen, but it did happen last week one day. Give me 1 minute. See if I stop this. Let me just open it again and see if maybe it was just PowerPoint was frozen. Okay, let's see if it's one of our figures. Okay. Alright, I think PowerPoint had just frozen for a minute. So we'll come back and talk about flowers. So the plants sometimes have to be a certain age to produce flowers, but then once they start producing flowers, there's of course all kinds of terminology. Just like every other part of the plant, there's a tremendous amount of terminology that goes with flower parts. So you can have the reproductive parts are the pistil and the stamen. The pistil is the female part. And it's composed of the stigma, which is the very top, the style, and the ovary. And that one I can always remember because I think about a woman carrying a pistol. Sorry, man, that's just how I can remember it. So the pistil. And the male part is called the stamen, and to me it's kind of like the name Stanley. So the stamen is the filament, which is the thing that holds the anther, the pollen-bearing part, up out to where pollinators hopefully can brush by it or get the pollen. In addition to the reproductive parts, we also have the petals. So the petals being the colorful part to attract pollinators and to incidentally attract us. And the petals, when we talk about all the petals together, that's called the corolla. You don't see that term a lot, but that's what that is, all the petals together. And then some flowers, but not all of them, have these little green leaves at the base called the sepals. And we talk about all the sepals as one. We talk about it as the calyx. So you will see those terms occasionally in botanical references. So flower has lots of parts. It can be kind of fun to dissect flowers and try to find the parts and name them. It varies a lot from flower to flower, exactly where they are and how they look all the way down. But it really becomes important to know just those basic groups, the sepal, the petals, the pistil, and the stamen, when you're trying to figure out if this plant is going to be self-fertile or if it needs another plant to cross-pollinate it. Because we have some plants that have complete flowers, meaning they have all these parts, and we have other plants that have incomplete flowers, so something's missing. So it can just be lacking the sepals, and it's an incomplete flower. So to us, it would still just look like a normal flower. But botanically, it would be incomplete. Where it really becomes important for incomplete flowers is whether or not they're perfect or imperfect. So a perfect flower has both the male and female parts. So it should be able to pollinate itself, although some perfect flowers, plants are intelligent enough to know that inbreeding is a bad thing. So they will not accept their own pollen. But in most cases, a plant can pollinate itself if it has perfect flowers. But in others, there are imperfect flowers. So imperfect flowers are missing either the male or female parts. So that flower needs another, so it just has female parts, it needs a flower with male parts to actually pollinate. And so plants that have imperfect flowers, there's also two different groups. They can be monoecious, so mono being one, Isha somehow comes house, so they live in one house. So monoecious is like people living in a monogamous relationship, a male and female together in that one house. So they're both on the same plant. So it has male and female flowers on the same plant, although some are only male and some are only female. So things like cucumbers, all of our cucurbits are melons. Some plants are male and some plants are female. Flowers, I'm sorry. Some flowers are male and some flowers are female. In other cases, we actually have dioecious. So two houses. This is where you had a divorce. And the males live on this plant and the females live on this plant. So you have to have two totally different plants growing close together for cross-pollination to occur and fruit to form. Hollies are a really good example of this. Kiwi fruit. Anybody here grow kiwi fruit? You ever notice when you order kiwi fruit, you usually have to they come as a pair. You have to order a male plant and a female plant. Or sometimes they can just graft a male branch onto the female plant. So you have to have that whole separate plant to pollinate the female. So we'll look at these a little bit more. So monoecious, one house, separate male and female flowers, but on the same plant. An example is corn. So the male flower is the tassel up at the top. The female flower is actually, doesn't have petals or anything, it's just these long pistils, is the silks that come out the end of the ear. And each one of those silks attaches to where the kernel becomes the corn kernel. So when you have an ear of corn and you got sections of kernels that aren't well filled out, that means those silks weren't pollinated. So it was poorly pollinated. Yeah, so here's the squash flower. So you probably noticed whenever you grow cucumbers or squash, they will start blooming, and it's like for the first couple of weeks they make all these blooms, but they will make no fruit. And for some reason these cucurbits, that's just a habit they have of only producing male flowers first. I think they have to come out and scout the territory and make sure it's safe for the females. So no matter what you do, you're just going to get male flowers the first few weeks, and you can tell if you look on the interior, you can see the difference in the reproductive structure. The male just having the stamen in the middle, and the female having this more complex But it's easier just to look at the stalk that holds the flower up. And on the male flower, it's just the flower attached to the skinny stalk. Whereas on the female flower, you have that big ovary already back there, that little fruit. It's already there waiting to swell up. If it doesn't get properly pollinated, then it'll just kind of shrivel up and fall off. So you can tell the flowers on those. Oops, I keep pushing the wrong way. And it's not just limited to vegetables. There's definitely woody plants that are monoecious. So tag alder, which is one that's coming out and blooming now, where you have the male flowers are these catkin type flowers. They make a lot of pollen. The female flowers are these tiny little red, bristly looking things at the tips, and they expand to become these cone-like structures. Not a true cone, but it looks like a little tiny cone and it holds the seed. So those were last year's female flowers that became seeds. So that's a close-up of the female flower, and that's where it develops into the seed-bearing structure. So those are all monoecious, separate male and female flowers on the same plant. Then we have dioecious, which is two totally different plants. So you have to have a male plant and a female plant. And of course, holly is a great example. You'll notice holly trees growing in the wild. Some of them will never, ever, ever have berries because they must be what? Male. Yeah, the male holly tree will never have berries. Most of the cultivated varieties we grow are female. And because we have so many hollies in the landscape, and we have like the little dwarf ones tend to be males. They don't produce berries like the Carissa holly. Hollies also are pretty good about cross-pollinating one species to an next. So a lot of times with our evergreen hollies, we don't have to worry about planting separate males and females. But with some of our deciduous hollies, like winterberry, you will get much better berry set if you intentionally plant a male. But so the male flowers, you can see the structure is quite different. You have the pollen-bearing structures. The female, you already have that ovary there in the middle. That's going to become the berry. And you get both of them close enough to go for the bees, because it is bee-pollinated, to pick up the pollen on the male and take it to the female. You get lots of nice pollen berries. And this really also becomes important, like anytime we grow a plant for its fruit, knowing, what, if it has special requirements, if it needs a separate plant for pollination. And then again, in fruit trees and in any plants, whether they're perfect flowers with all the parts or whether they're monoecious, some plants will not, as we said before, accept their own pollen. So you have to have a separate variety or a different seedling. They have to pollinate. It still is pollinated by a plant of the same genus and species, but not itself, and not a clone of itself. And you see a lot of discussion around this with fruit trees, that some are self-fruitful, like peaches. Peaches and plums are self-fruitful. You don't need to worry about planting a separate one. But a lot of our apples and pears, even blueberries, they, on their own, if you just had one apple tree or one blueberry bush, it would make some fruit, but you would get a lot more fruit if it gets cross-pollinated by a different cultivar. So plant a golden delicious apple and a gala apple, and cross-pollinate each other. Plant Premier blueberry and Onslow, or have a couple of different varieties. And pollination typically happens, there's other ways, but the big two groups of pollination are wind pollination and insect pollination. Of course, there's some plants that are pollinated by bats and hummingbirds, and there's some plants that are pollinated by water moving the pollen, but most of them it's either wind or insects. And the wind pollinated plants are the grasses and some of our trees. That's fine. Sorry. That's the next meeting my computer kept telling me about. So the wind pollinated plants tend to produce a whole lot of pollen because they just are relying on the wind to move that pollen around to the flowers that just happen to be somewhere. So I don't know if you've ever watched any of the nature documentaries about how corals and things reproduce, and you just like send all this stuff into the ocean and hope it meets up somewhere. That's kind of like a wind pollinated plant. They're just throwing out all this pollen, hoping that some of it's going to land on the female flowers that are somewhere just out there. So wind pollinated plants tend to be those things that make tremendous amounts of pollen that's very light and becomes airborne. So if you have any allergies, that's what's triggering hay fever most likely is your wind pollinated plants. Wind pollinated plants typically have no petals. You don't even, like most people wouldn't even look at them and think it's a flower, because they don't need them. Because petals and color and fragrance are all about attracting insects. So why do it if you don't need to? So our insect pollinated plants have the colorful flowers, the fragrant flowers, and this is a type of goldenrod. So a lot of people blame goldenrod for hay fever, and you can definitely have an allergy to goldenrod, but in most cases, goldenrod is not the pollen you're reacting to in the fall. It's more likely ragweed or some of these grasses, these wind pollinated plants. So we see a lot of our native trees, our oaks, birch. What's another group of them? There's another group I can't think of my mind, but pines. They're all wind pollinated, and that's why you tend to have a whole bout of hay fever in the spring. Then as we move into the summer, we get all the grasses coming out and ragweed. Ragweed, these are the flowers that are open on ragweed. They come out and start blooming when things like goldenrod blooms. So the more colorful plants get blamed for the wind pollinated plants. Then you can see the big difference with the insect pollinated plants. You have color, you have petals, you often have fragrance. If it's a sweet fragrance, that usually attracts things like butterflies and bees and moths. There are some plants that smell like rotting flesh that actually tend to be more jungle type plants. They attract flies or beetles as their pollinators. We don't tend to want to grow those in our landscapes. We tend to go for things that are pollinated because they have nice pretty petals, colorful petals, or nice fragrances. And there's just really interesting to start studying flower shape and pollinators, flowers. Flowers that kind of open up like that daisy-shaped flower. You see a lot of bees visiting them, butterflies, it's kind of like a landing pad. Whereas for things that are pollinated by hummingbirds, which just flutter, they never stop. They tend to be narrow flowers that face sideways, so the hummingbird comes in and can feed on the nectar, but in the process of feeding on the nectar, they are moving the pollen around. It's also really interesting to look at flowers the way insects see them, because insects don't see like we do, they see ultraviolet light. And there's a whole website, and I did not put the link up here, there's a website that has pictures of all different plants. Normal light like this versus ultraviolet light. So the insects see it, they really want to, the plant wants to have like a target, come here, land in the right place, this is where you want to go. And I remember in college I took botany, and one of the labs we had a UV light. We looked at some flowers under UV light. And one of the azalea blossoms, like it had arrows pointing in right to the middle, this is where you want to go.
Excuse me.
Yeah.
Can you go back one, just one, the lower one on the morning glory.
Mm-hmm.
That looks like a hawk moth.
It's a type of hawk moth.
It's not a hummingbird.
Right, no, that one's a hawk moth.
And so those are really beneficial. You see them a lot in the summertime.
Well, they're good pollinators for certain flowers, but the larvae of hawk moths are hornworms. So, like there's several species. So tomato hornworm, the moth is going to be one of these type of moths. These are mostly sphinx moths, I believe. But yeah, they are wonderful to watch as they go around and pollinate things. That's moonflower, so it opens up in the evening. Okay. And then why do plants want to have flowers and pollinated? To make seeds, and they want to make seeds so that the whole species continues, so that they continue to exist on Earth. So that plants, in a lot of ways plants aren't like people, but in a lot of ways plants are like people, so they want to pass on your genes to the next generation. And that's what fruits and seeds do for plants. Fruits are actually just there to help distribute the seeds, just like plants make pretty flowers to draw in the pollinators. They make the fruits to attract other animals to move their seeds around, so they get moved further away. And one thing about fruit, so particularly like an apple or a cucumber, a fruit contains the seed, but fruits are the product of the mother plant, so they're the product of the plant they're growing on. So we talk about apples, and you get much better fruit set if you plant two varieties. If you have a gala apple and a golden delicious apple, and they cross-pollinate each other, how do you end up with gala apples on that gala tree? Well, that fruit that forms around the seed is the mother plant's genetics. So it's still a gala apple, but the seeds that are inside the apple are the product of that cross-pollination. So if you would take those seeds and grow them, you would get something totally different. It could look really similar to the gala, it could look like the golden delicious, it could be all in between. So keep that in mind when people say, my cucumbers are bad, I think they got pollinated by squash. That's not the case. Just because the cucumber itself is a product of the mother plant's genetics. It's the seeds inside. So you do get bitter cucumbers if it's been really dry or hot. That's probably what happened. Sometimes, now you can buy seeds occasionally, because some of the cucumbers do cross-pollinate. And you might buy some seeds that were product cross-pollination, and something weird grows from it that's not what you expected it to be. And that was where something strange happened in the field. All right, and then leaves, and we'll probably have to finish up.
Can I ask a question about flowers first? So we're talking about nectar. Do all flowers produce nectar, and what part of the flower produces nectar?
The nectarines. There's actually part of the flower called the nectarine that produces, it's the female part of the flower, or it's usually associated with the female part, although some plants can have nectarines on other parts of the plant. But nectar is all about attracting pollinators. So nectar is going to be for insect pollinated plants. So it's sugar, it's concentrated sugar water. So the plant's taking some of the carbohydrates and things it produces in its leaves and kind of sacrificing it, putting it out there for to attract pollinators who want that sugary water. So only your insect pollinated plants are going to produce nectar. All right. So with leaves are the last part we're getting to. They're an extremely important part of the plant because they produce the food. So a lot of times people think about when they fertilize the plant, what do they think? You're fertilizing, you're feeding. You're not really, because the true food of the plant is produced in the leaves through photosynthesis. That's where these carbohydrates are formed. Now, for that photosynthesis to take place, the plant does need certain minerals that are provided by the fertilizer. But the fertilizer itself is not directly plant food, but it's pretty essential to the process. So leaves are all about food production, and they need to come in contact with sunlight to have photosynthesis take place and produce that food, which is the energy that lets plants grow and lets plants bloom and produce fruit. And so it's all in these green tissues that this happens, where you find the actual chlorophyll, which is where photosynthesis happens. So when you have plants that are variegated, you are missing chlorophyll. So that plant doesn't have as much chlorophyll, so it's usually not going to be as vigorous. So you find the variegated plants, they tend to not be quite as vigorous. They often want to get back to that being all green state, so they may revert. They may send out a shoot that just has green leaves on it, and all green leaves are going to have more chlorophyll, so it's going to be more vigorous, and it can easily overgrow the rest of the plant. So we talk about a plant reverting. That's what's happened. A green portion has come out, like we see in this picture. This is a type of Japanese maple called butterfly that's very, very, very variegated. Some of the leaves are just all kind of green colored. But because it's got such limited chlorophyll, it's constantly wanting to get back to a state of being able to feed itself more effectively. So it'll push out these sprouts, these new shoots, these kind of water sprouts that have all green leaves. You don't cut them off, pretty soon they'll overgrow the whole plant. They'll just have a green plant.
So are variegated plants usually cultivars?
Yes, yeah, variegation is a kind of anomaly that happens, and it does happen naturally, but plants don't want it. So variegated plants don't tend to survive a lot in the wild, but we really like them, so we keep them going. We propagate them into almost always it's going to be a selective cultivar.
What about plants that are green as well?
Yeah, some plants have different pigments. I've got a slide that talks about some of the different pigments. So yeah, naturally there are other pigments other than green. And so the chlorophyll's still in there, it's just kind of being masked by some of these other pigments. When we look at leaves, of course, so much terminology around leaves. So much different terms to describe every part of the leaf, including the edge, the top, the base, and if you start talking about plant ID, those things get really important. And the devil's in the details, and there's a different name for every leaf shape and every edge of the leaf, the top of the leaf, the bottom of the leaf. So you can really get deep into some terminology with those kind of fields when you get into plant ID. But usually we think about the blade, which is the broad part of the leaves, the midrib. Not every leaf has a solid midrib. Some of them have the more divided midribs. In the monocots, they have the parallel veins. Then we have the petiole. So you'll sometimes see that term petiole, and that's just the leaf stalk. That's the little stem that attaches the leaf to the twig or to the stem. And some plants have no petiole. They're called sessile. And they tend to look kind of strange because the leaves are attached right directly to the stem. So this is a juvenile eucalyptus, which has, you think about eucalyptus, they're sessile, they have no petioles. The leaves go right onto the stems. Forgetting which way up, which way down. On the leaf is a cuticle, which is a waxy covering to protect the leaf from drying out or from sun scorch, kind of UV protection. It helps repel water. Some plants have a much thicker cuticle, so a lot of evergreens especially, if water falls on their leaf, it just kind of beats up and rolls off because the cuticle is so thick. And evergreens have that thick cuticle to help them protect them in the winter from desiccation, so it keeps them from losing too much moisture. So on evergreens you'll find more well-developed, a thicker cuticle. And the cuticle helps, as I mentioned, protect plants from sunburn. And when it takes time for that cuticle to form, and it'll vary. If you plant something in full sun, it will have typically a thicker cuticle than if it's planted in a lot of shade. It doesn't need as much of a thick of a cuticle. But if you move the plant, say you had a hosta in full shade, and you either moved it or you cut the tree down that was causing the shade, so there's a sudden change from shade to sun, you will get sunburn because there wasn't enough time for the cuticle to form to add that extra protection. And in some cases, some plants, if they are shade plants, will never form enough of the cuticle. Hosta shouldn't be growing in full sun. It's always going to look good up there, but especially to start with. And I always, forget about this, and in the spring, just take my houseplants out, put them in the full sun, and they all get sunburned. Yeah, I should have put them in the shade and parked them for a couple of weeks before putting them out in the full sun. And here's the pigment. So chlorophyll is green, and it gives plants the green look, but there are other pigments there that can mask the chlorophyll. So chlorophyll is still there, but the other pigments are just coloring the leaf. So the carotenes and the xanthophylls are yellow, and then the anthocyanins are the purple and red. So you think about some of these purple leaf plants like Japanese maple, they have a lot of anthocyanin in them. And one thing you notice with chlorophyll is it breaks down at 32 degrees. So that's why we get fall color, is the chlorophyll was dominating a lot of these leaves up until we started to get below freezing temperatures. Then as the chlorophyll starts to break down, some of those other, the carotenes and the xanthophylls start to come out. You start to see them. The chlorophyll is masking, but now they're what's there giving the leaf color. And that's why we get fall color. And with our warm falls and taking a while for it to cool off, especially with cooler night temperatures in the fall. That's why we don't tend to get the dramatic fall color like in the mountains or in the Northeast, where they get those cooler nights earlier in the season. So we're going to skip this part. This was something that I put in there if we had time, and I was kind of thinking we wouldn't. So we're going to finish up. I do want to talk just a little bit about growth processes because they really fit with the leaves, and a lot of this happens through the foliage, and it's a really important part of plant growth. Actually, this is the website, and it's in the version posted online. These extra slides we skipped are in the version posted online, where you can go and practice and learn more about a lot of that terminology related to plant ID and, describing leaf shapes and different types of buds and, all of that vocabulary related to plant morphology and plant anatomy. So, we talked about leaves being where photosynthesis takes place. And photosynthesis produces carbohydrates, which are the plant's energy. There is food and what fuel its growth. And so for plants, that energy is kind of like how we use money. Money for us lets us get what we need. And so if you have some money, you have some options, right? You can go out and just spend it and say, I'm hungry, I'm going to buy something, get something to eat it. What else could you do with the money? You could save it, so I'm not hungry today, I'm going to save it, and I might be hungry next week and have no money, I can pull it out and use it, right? What else could you do with the money?
You can lend it out.
Yeah, you could invest it. So you could put it somewhere that's not immediately accessible to you, but in the future, hopefully it's going to pay back more. Or you could give it away or lend it, like you said. You could give it to somebody else. I have more money than I need, so I'm going to give some to somebody else. So exactly. So you can do these things with money. Something you need right now, spend it, save it for the future, or invest it for the future, and hopefully it's going to pay off, or give it to somebody else. So you don't directly benefit, but they do. So plants can kind of do the same thing with energy. They can spend it to grow. So they make some energy and they can use it right away to grow, to get bigger, to make more leaves, to make more buds, or to defend themselves. So plants also produce a lot of natural chemicals that they are able to defend themselves or help defend themselves against pests and diseases. So that's spending it right now. They can save it, like they can put it in a root, or they can put it in some of those storage structures, those modified stems, so it's saved up for the future. And so they can go dormant for a time and then get ready and start growing again when they don't have any leaves at that point, but they can push new leaves out by using that stored energy. They can invest it, and really for plants, investing is like making seeds. They're not investing it for them as an individual plant, but they're investing it for the good of the entire species. They're continuing that species. Plants do not like to give it away, because giving it away means something came along and ate it. A deer, bugs, slugs, or gardeners, we came along and took something off the plant. So to be able to do, but we as gardeners really want plants to be able to give some of their energy away. So for that to happen, they have to have extra energy, right? To make enough leaves, or make enough seed pods, or to make enough flower heads. So in the case of broccoli, or harvesting a flower head, you want to be able to harvest it, and then you want the plant to make some more. For broccoli, they'll push out those side shoots, or for kale, you can harvest some of the leaves, and they'll grow more leaves, you can harvest some more. So we want them to keep making energy, and to do that, they really have to have sunlight, they have to have water, they have to have carbon dioxide, which comes in through the leaves, and although it's not here, there's also minerals. There's minerals that are taken up with the water. That's the nutrients through fertilizers, or hopefully, there's quite a bit there naturally in the soil by adding things like compost and organic matter. So really it is sunlight. Sunlight is what drives plant growth. Sunlight in the presence of chlorophyll, which is in the green tissues, with water, with carbon dioxide. It does take some oxygen too. With those minerals, makes those carbohydrates. It releases oxygen, which is really good for us. We like to breathe oxygen. And it lets plants grow. It lets plants make fruit. It lets plants make seeds. So some things about photosynthesis is it only occurs in light. So we don't have photosynthesis at night. It only occurs in those cells that contain chlorophyll, which typically look green, although there are some cases where other pigments mask the green, but it's still there. It does require water. It does require carbon dioxide, and it releases oxygen. So how do those plants get carbon dioxide? They have to take it in through little openings in the leaves called stoma or stomata, all of them. So when you look at them under a microscope, really high-powered microscope. They look like kind of two sausages, and they open up, they swell or kind of de-swell to open up or to close. And they open up when the plant needs carbon dioxide, and they close when the plant needs to conserve moisture, because they're also losing moisture through these stomata. So anytime a plant is wilted or stressed, it'll close those stomata so that it doesn't lose moisture. And photosynthesis pretty much shuts down for most plants when the stomata are closed. So anytime a plant's stressed, it's really not photosynthesizing. So they, in addition to taking in carbon dioxide, the stomata also release moisture. It's called transpiration. It's kind of like plants sweating. Plants don't sweat, they transpire. And they need to transpire because that's part of what builds the turgor pressure that kind of keeps them standing. You know, that is, from a physics standpoint, is what keeps water moving. It helps draw some moisture from the roots and pulls it up through the plant. The fact that you've got that pressure being pushed up through and keeps them turgid, keeps them, you know, upright. So we always have to have enough moisture in the soil that the roots can take up to keep the flow of water going through the plant. And it's pretty amazing how much water a plant can kind of process in a day, move through, take up through the roots, move out through the leaves. So there's somebody's calculated that an acre of corn will give off up to 4,000 gallons of water a day. One large oak tree can transpire 40,000 gallons of water a day. So there's a lot of moisture being circulated, you know, kind of moved from the soil back out into the air, or hopefully it goes back up to the atmosphere and becomes moisture, you know, raindrops and comes back down. So plants are a really important part of that whole water cycle, so much so that in areas where there's been really dramatic removal of natural vegetation, you actually have areas becoming desert. So desertification, can happen. And in some areas where this is happening, there's been huge projects to go restore plant material to try to bring that natural cycle back in and reverse that process. So photosynthesis is really critical for pretty much everything we want plants to do to happen. They have to photosynthesize to grow, to make flowers, to make fruit, to make seeds. So we want them to do it, you know, the best they can. So we want them to have the sunlight they need. You have to have sunlight for photosynthesis. There's definitely a genetic component, and that's why we can't just grow any plant here. Some of it is cold tolerance, but some of it is also that plants don't like heat. Some plants are not adapted to grow in hot climates, because in hot climates, they don't photosynthesize near as well, and they just can't make enough food to survive. So temperature, the optimum temperature range for most plants, and of course there's some groups of plants that have adapted and can photosynthesize well above 85, but in general, it's 65 to 85. So we have a lot of summer days over 85. So we have a lot of our summertime that plants they're kind of struggling. It's not optimal. And you know, you can look at the whole world's been divided into different climates, zones. We're here in this zone that's kind of a warm temperature, humid, hot summers. And you know, thinking about the genetic potential of plants to perform well in that type of climate. Of course, things that are native here, but a lot of plants that come from Japan and parts of Asia have that same type of climate, and that's why we see a lot of our ornamental plants are from that part of the world, because they're just naturally adapted to our climate. Whereas we have very few ornamental plants from Canada that we grow here in North Carolina because it's just too hot. They cannot photosynthesize well at those higher temperatures. And because of that, the American Horticulture Society actually created this different type of map, a different way of looking at climate versus just how cold does it get, but how long does it stay hot? And you can see it's geared to number of days over 86 degrees, because that's the point where most plants, photosynthesis starts to kind of become less efficient. So this American heat zone map never caught on. It's still out there. You can look it up, and it's very interesting. you know, ideally, they initially wanted it to be like printed on all plant labels. It never quite made it to that stage. But they published a couple books about it, but it's a really interesting and helpful way to look at climate. Not just how cold it is, but how long it stays hot. So we're here in the 7, where it's 60 to 90 days. We just happen to coincide with our cold and our heat zone being the same. So we typically see 60 to 90 days over 86 degrees. So that means plants are going to have a lot of hot days. And our winter hardiness zone is also 7. If we were to pull back up that winter hardiness zone for 7, we would see most of the coastal west coast is also zone 7 for winter hardiness. But if you've ever been to the coastal northwest, you know they grow very different plants than we grow here. And they grow a lot of things we can't grow. And it's not the cold that's the reason, it's the heat. You can see over here, they are much, much cooler. They have many days less than 86 compared to us. So that summer temperatures for us really tend to be much more limiting factor for the plants we can grow than the winter temperatures. So the poor little plant, when it's wilted, usually because there's not enough moisture, photosynthesis is not happening. The things like water availability really affect photosynthesis, nutrient availability, because the process of photosynthesis requires some of those minerals. And like really windy temperatures and when the humidity is really low cause plants to wilt faster because they're transpiring more water. So when we have those conditions, sometimes in the spring we get those low humidity, windy days. High fire hazard days tend to be days that plants aren't photosynthesizing very well because they're closing their stomata. The opposite of photosynthesis is respiration. That's how plants use that energy to grow. So that releases the energy and lets them grow, it lets them defend themselves or reproduce. And the really important things, I'm just going to go to the next slide, because if you compare photosynthesis with respiration, you can see some really key differences. One, that photosynthesis has a lot more limitations on it. It only happens in the daytime, and it only happens in the cells with chlorophyll. And over 85, it becomes less efficient. On the other hand, respiration, it happens day and night. Plants are always respiring. They're always using energy. They're only making energy in the daytime. It happens in all cells, not just the green parts. And it increases with temperature. So our hot summers, and especially our warm summer nights, are really hard on plants because they're respiring a lot. Their respiration is speeding up because the temperatures are warm, but photosynthesis is kind of limited. So again, that just kind of reinforces why our summers are the tougher time for most plants in our climate. And in situations where you try to take plants that are adapted to much cooler climates and grow them here, they just don't survive because they can't make enough. They can't make enough energy. They kind of have a cash flow crisis, so they go bankrupt. They spend more energy than they can make. So that's why, you know, a lot of people when they first move here might want to try to grow a Colorado blue spruce, so they might want to try to grow a lilac, or, you know, there's plants that did really well in a colder climate if they came from one. They just aren't going to survive here because of our summer heat. All right, I think I'll finish it up there. This kind of talks about what is the result. Actually, let me just mention a couple of quick things. The real impacts we see when we have these hot days are in our vegetable gardens, hot days and warm nights. Production really shuts down. Tomatoes are really sensitive. Cucumbers, you know, when those days get in the mid-90s, the nights, it's only in the upper 70s, those plants are just doing all they can to stay alive. So if we have a heat wave, you'll definitely see an effect on productivity in vegetable gardening. Plants that are stressed for these reasons also tend to have more pest problems, particularly things like aphids and scale. And then, of course, ultimately you could end up into real food shortages for certain things. You know, that things like tomatoes, every now and again you see certain things just aren't there in the grocery store because of weather-related issues. Okay, I'm going to leave this is a little worksheet, that since you guys already did your homework, right, there, kid, you can do this for homework, so yay, you still have homework. And I will send Ashley kind of the discussion answers for you, and you can look at, because this is kind of taking what we just looked at, and thinking, how does it affect what happens in our bodies and how our plants grow. So it's a sheet with some questions on it. And I did just want to mention this one resource, if you are interested in about climate change and how it could impact agriculture particularly, there is a great report out from USDA that talks about how the higher temperatures will affect things like crop production. And that we're already seeing, especially these warmer nights in the summer, which have a big impact on our summer vegetable production. Okay. All right, thank you.
Yeah, and just so you all know, I will post the worksheet today, and I'll probably post the answers in a week, so you have a little bit of time to kind of think over that and look at it before you can just see the answers, because I know, sometimes we read books by starting on the last page, and it's not easy to do it. I'll also post the PDF of the slides from today, and just send out a little bit reminder of just what to do to get ready for next week.
And the website that Charlotte mentioned at the beginning.
Yes. Yes, that will.
Yeah, the links is the bottom one.
Oh, okay.
It's in the slides.
Okay.
So it'll be the slides that, the PDF that actually posts, the slide will be there when you click on it.
Just by the end.
It's there kind of in the middle. Or you can copy it. It's the one, the bottom one.
Okay, so yes. And we'll be hanging out for a little bit to give questions. Got it. So the name tags you got today, you can hold on to for volunteering. And just, but do hold on to them. For volunteering, for meetings, that kind of stuff. Yes. This will be like a bit of a name tag training. Oh, yeah.